Hello, welcome back to the Particle Technology course. So, you all know that this is the LMS initiative of the Department of Collegiate and Technical Education. So, we are in the discussion of the second unit of the Particle Technology course. So, in which we have already finished studying a few topics under the first two sessions. So, today I am taking up the third session. So, let us just recall whatever we studied in the previous session. Um, in the last session, we discussed about the methods for determining the particle size of the given sample. So we discussed in detail about the sieve analysis procedure for particle size determination. In that, we learned how we have to report the results obtained in a sieve analysis method and what is a differential method of sieve analysis and cumulative method of sieve analysis. So all this we discussed in detail. For today, so we are starting with the screening operations that are carried out in industries. So what are the objective of screening operations? Then we need to discuss the different types of screens that are used in industries and what are the different kinds of motions that are incorporated in different types of screens to separate the given material according to size. So afterwards, we need to take up the different types of screens one by one to study their construction, working, application, and other details. So for today's class, I am considering the stationary screen, also called as Grizzlies. So coming to the definition of screening, it is a method of separating the solid particles based on their size by using screens of known opening sizes or apertures. So that method is called screening. So basically the screening operation involves the mixture of solid particles are taken and dropped on a screen that acts as a go and no go gauge. Means the screen particularly has the ability of not allowing certain particles to pass through and only allowing some particles to pass through. So that depends on the size of the opening in a screen. So that is what is known as acting as a go and go gauge. The material which passes through the screen is collected as one product called the undersized fraction or the fine fraction, while the material that is retained above the screen, that is on the screen, is called the oversized material or oversized fraction, or it's also called as tails. Industrial screens are made from metal bars, woven wire cloth. So just like your standard screen is made, then silk bolting cloth or perforated or slotted metal plates. So these are some of the materials that are used for constructing industrial screens. Okay, what are the objectives of screening in industries? It is various necessities which require screening operations in industries. The first requirement is to remove the feed fines from feed material before the reduction equipment such as jaw crusher, ball mill or rod mill. See, the various size reduction equipments will operate and give the required amount of size reduction based on the size of feed and the size of the product. So, to feed a material to a size reduction machine, the material that is used should be free from fine solids. So, otherwise, the material that is already has undergone also enters the feed, enters the size reduction machine, and its performance means the capacity gets reduced. So to remove the fines from the feed that is to be fed to a size reduction machine, screening is done. That is, the material before it is fed to a crusher or a grinder is to be separated out of all the fine particles that may be present. That is one need. So whenever crushing operation is done, the material coming out may contain some particles which are still not reduced in size to the required extent. So that product from a size reduction operation cannot be just passed on to the next operation, because maybe the next operation strictly requires particles of certain size. So here you have to separate the product coming out of the size reduction equipment, so that if there are some oversized materials or oversized particles, so that will be separated and sent back for sufficient size reduction, while the particles that have undergone the required size reduction will be fed to the next operation. So that is to prevent the material entering the next operation without having undergone the required amount of size reduction. That is another reason why we need a screening operation. The next requirement of screening is to produce a commercial or a process grade product to meet specific particle size limits. Whenever a product comes out of an industry, it has to satisfy certain specifications. Means to meet the requirements, the grade of the product should be maintained at certain values. That is, the particle of a product should be of certain size and it should satisfy certain qualities. So the product before it is sent to the use is to be separated from all the particles which are not meeting this specification. So in that case also you require a screening equipment. So whenever a product comes out, it will be stored in the storage facility in a industry. So during that storing or conveying or handling, the product particles may undergo degradation, means they may break into smaller sizes. So these fines or degraded material should not be sent to marketing. So because that will be considered as a lower quality product. So in order to see that the degraded product is removed from the quality material, you need to carry out the screening operation. So these are some of the areas where you require screening operations in industries. The important types of screening equipments that are used in industries are based upon the movement involved in a screen. So usually industrial screens are given certain kind of movement so that the materials will not have any difficulty in passing through the apertures of the openings. So in order to assist the screening operation, the screens are given certain mechanical motions. Based on that, you can classify the different types of industrial screens. So accordingly, we have these types of screens. The first one is the stationary screen. Here the screen is not subjected to any kind of movement. So these are also called as fixed screens. They're also termed as grizzlies. Then comes the trommels. These kind of screens involve revolving action for screening purpose. Then you have a shaking and vibrating screens where the screens are vibrated or subjected to shaking mechanically or electrically. So that is another kind of screen that is used widely. Then you also have screens which oscillate, in which the oscillating motion is involved to carry out the screening operation. So these type of screens are used for particular type of material. So grizzlies are used for core screening of large lumps. So these are the ones where the big lump-sized solids are subjected to separation to see that the fine particles are separated from them. So usually the material that is fed to a primary crusher will be in the form of big sized lumps. So this material before being fed to a size reduction equipment is subjected to screening to remove if there are any fine particles present. So that is where the grizzlies has found some application. So then trommels or revolving screens are used relatively for larger particles. Then shaking and vibrating screens are more suitable for fine sizing, fine material separation. So they can also be adopted for coarse range also. Then the oscillating screens are mainly employed for the finer material of a size below 4 mesh. So this typical diagram shows how the different kinds of motions are given to screens. So I told you the importance of motions that are given to screen in the previous slide. Whenever a screening of material is carried out, coarse particles will easily drop or pass through the large openings if it is a stationary screen. But the fine particles will have some kind of difficulty in entering and passing through the openings of the given screen. In such a case, the screening should be given some kind of assistance by shaking or gyrating, by oscillating or revolving, either mechanically or electrically. So then a suitable kind of motion is adopted for a given screen to assist the screening operation. Okay. So as shown in the diagram, different kinds of motions are given. The first figure shows the gyrating action of the screens, where the two screens are mounted one above the other. The screens gyrate in a horizontal plane. Then the second figure shows the gyratory motions taking place in a vertical plane. The third figure shows the combination of gyrating action as well as the shaking action. One end is gyrated, at the same time the other end will be shaking, that is involved in forward and backward motion. So like this, a combination of motions can also be used, or a single type of motion can also be used. The fourth figure, figure D, is indicating the shaking action of the screens. And the fifth diagram E shows the vibrating action. Here, mechanical vibrations are given by incorporating an eccentric, so which conveys the vibrating action to the screen. Then, electrically vibrated screen is shown in the last diagram. Electrical vibrator is directly transferring the vibrating action to the screens as shown in the diagram. So that is how the different motions are incorporated in the industrial screens in order to help the screening of the material. Okay, now we are taking up the stationary screen to see how it is constructed and how it is operated. So figure shows a simple line sketch of a grizzly screen. So it is a top view what you can see in the diagram. A grizzly is a screen that consists of a set of parallel metal bars. The metal bars are fixed in such a way that they are inclined to the stationary frame. So at the bottom you'll have a frame. So to that frame they are inclined with a certain angle of around 30 to 45 degree. The slope and the path of the material are usually parallel to the length of the bar. So usually the path of the material means how the material flows over the screen will be usually parallel to the length of the bars. The length of the bars may be up to around 3 meters, and the spacing between the bars is around 50 to 200 millimeters. The material that is used for constructing the bars is manganese steel to have a wear-free construction, so that the material is chosen to withstand the abrasion. Each bar is provided a specific kind of a shape. The top edge of the bar is wider compared to the bottom edge. So, with this kind of construction, we can make a stronger bar having a certain depth, and also if such kind of bars are made, then the choking of the space between the bars do not occur. So that can be minimized by having a construction of bar in this manner. So at the side you can see the diagram showing the cross section of one single bar. So you can see that the top of the bar is wider compared to the bottom. So this kind of construction is usually given to the metal bars in a grizzly screen. Okay, coming to how it is operated. So you can see that at the bottom there is a frame, and at the top of the frame a number of parallel metal bars are fixed such that they are inclined to the horizontal at some angle of around 30 to 45 degree. So usually the upper end of the bars or the screen is the feed point, that is where the material is fed to the equipment, and at the lower side you can collect the coarse particles, means the particles which slide over the bars instead of without getting screened in the operation. So as we already learned that these are used for separating the big lump sized particles from very fine particles, that is to make the feed or the material free from small sized particles. Large chunks of solids roll and slide over the bars to the lower end. So where the coarse product is discharged, coarse means the tail product, as I said in the initial discussion, while this very small particles or the small lumps will pass through the spacing between the bars and get collected under the bars, that is a space below the bars is meant for collecting the fine particles that are passed through the openings in the given screen. So this is essentially a dry separation operation. Dry material is used for is subjected to size separation here. It is not suitable for any material separation in a moist or sticky condition. So because since the screen is stationary, the moist particles may not slide or roll over the screen surface that easily. So that is why this type of screen is not suitable for a wet size separation operation. So it is essentially a dry size separation that is carried out using a grizzly screen. So coming to its application, as I mentioned in the earlier stages itself, a grizzly screen is suitable for separating fine particles from very large particles, so which are supposed to be made as a feed to a primary crusher. Primary crusher takes the feed in the form of a very large sized lumps. So if those lumps are containing some fine particles or small particles, they are to be separated, and that is done in using a grizzly screen. So compared to all other screens, this is the most simplest one because its construction is very simple, Also, it is not involving any kind of motion. No power is required as no movement of any parts of the screen is involved, and it is a very economical one and not an expensive one to install and also to maintain. So one problem with this screen is, as I said in the construction itself, it it has a tendency to choke. That is, if the particles get blocked in the spacing between the bars, get stuck in the spacing, so then that is called choking. That is, the openings in the given screen may get blocked by the wedge-shaped particles. Is the particles having elongated length. So in that case, labor requirement will be more in order to carry out the screening operation. So once the spacing is fixed for the given screen, it cannot be changed. That is another drawback of this type of screening equipment.